All right. So hi to everyone. This is Aerial Robotics. This is a lecture which will be given by Dr. Kimberly McGuire. I'm Fabrizio Schiano and a postdoc at LIS, as you know. And for me, it's a pleasure to present you Kimberly. And Kimberly has done her master thesis in mechanical engineering in bioinspired robotics at Delft University. She acquired her PhD at the same university at the Faculty of Aerospace Engineering with the topic Indoor Swarm Exploration with Pocket Drones. The project also resulted in a publication in Science Robotics in 2019, which we'll probably see some videos about it. And since June of 2019, she lives and works in Sweden at the company Bitcraze AB, which are basically the creators of the Crazyflie quadrotors. So the floor is yours, Kimberly, and looking forward to this lecture.
Oh, yeah, thank you for introducing me, Fabrizio. Well, it's nice to meet you all. Thank you, Fabrizio and Dario, to invite me or Bitcraze to do a lecture at EPFL. I'm sad that we're not able to be there physically. We really wanted to be there, but unfortunately, yeah, circumstances made it a bit more difficult. So now I wish you a warm welcome from my own personal kitchen, which is now currently my workspace and flight arena at the time, since we all work at home from Bitcraze. So how I'm going to do it is I'm going to do the lecture in two parts. So the first hour, I'm pretty much going to give an intro, an overview of everything that we do at Bitcraze, and I'm going to also give you an overview of the hardware of the Crazyflie, what you guys are going to use eventually. And the second hour, it's going to be more of the software part of size of things. So I'm going to talk about the state estimator implemented into the Crazyflie, the controllers, and I'm already going to assume that you guys already know what a state estimator is and what a Kalman filter is or anything like that. So I'm going to pretty much only show you the information that I think you guys should know. But if you have any questions, please ask them. I might not have enough time to constantly answer all your questions, but I definitely will try to do it every once in a while. Kind of depends how quickly I go through the presentation. So let me see where we are right now. So just to give you a quick introduction of what is Bitcraze. So we are pretty much the creators of the Crazyflie, and we focus mostly on hardware development. So that's what our business is. We sell the Crazyflie and is an accommodating ecosystem. And we do that from Sweden in Malmö, which is, if you don't know where it is right across of Copenhagen. Currently, we're all working at home, but that's still also Malmö. So all the team members here is from the top to bottom is Tobias, Marcus, Christopher, Arno, Barbara, and me, Kimberly. So I started working at Bitcraze since June last year. Barbara is our newest member, and we're still growing. Hopefully we'll still be able to do that with all the crisis going on. So a very brief history of how Bitcraze started. So it pretty much started as a hobby project of Tobias, Marcus, and Arno. They started their hobby project while they were actually working at another company. And that's kind of grew, and more people started to like the platform, the Crazyflie 1 that you see right here. That really took off, and they actually started to be a real company in 2009. And currently, we actually have an upgrade of the Crazyflie, which is the Crazyflie 2.0 and 2.1. So this is the one that the 2.1 are the ones that you guys are actually going to use, hopefully, eventually in your practicals. So, well, who uses the Crazyflie? So it's pretty much started out with hobbyists mostly that were really interested in the Crazyflie 1.0 at the time. But so it's only also a lot of researchers started to pick up the platform as well, because it's very small and it's very lightweight, especially quad-rotor researchers use it in their research. I've done it for myself during my PhD. And also recently, educators are starting to use it as well. So you guys are the prime example of that. You're actually going to use the Crazyflie to make you learn more about quad-rotors. So that's, yeah, and that's also a very nice development for you, think. And I guess also as a parallel track, there's also a lot of use of the Crazyflie in shows. So I have a nice example of that. You guys probably have seen this TED Talk, I would presume. So let me just put this a bit bigger. I don't know if you guys are able to see the video well, but you can, of course, the link is in the, should be in the slides. If you have the PDF, you can click on it. So yeah. So they actually used the, this was a TED Talk by Raffaello Deandro from, at the time, I think, ETH Zurich. And he actually used the Crazyflie 2.0 with their own, own positioning system. So that was already pretty cool at the time. Yes, all right. I think you pretty much get the picture, right? So that was one of the examples also that the Crazyflie is being used, and that's also getting quite popular. Okay, so we're getting now to the ecosystem. So what revolves around the Crazyflie? Well, of course, the Crazyflie itself. But it's not only the Crazyflie, we also sell the Bolt, which enables people to have a bigger platform, and also the Roadrunner for positioning. But we're mostly going to talk about the Crazyflie right here. So we also focus on, we have like open source software as well to communicate with the Crazyflie, which can be done both on the computer or the mobile clients. And we also focus on positioning system itself. So first, just a very brief overview of the Crazyflie. I'm going to go more into detail with this, but just to kind of show you a bit what it's about. It is a quad rotor. You guys know what a quad rotor is. So you have four motors, you have a battery, and you have also like standard microprocessors on that. So I will mostly focus on that later in this lecture. So just first a quick brief on the positioning systems that we have. So I guess you guys are familiar with motion capture systems. So you have an infrared light transmitter that sends out infrared light, and then you have markers on the Crazyflie or another robotic platform, which sends it and reflects it back into an infrared camera. So you can have very good precision with this. You have millimeter precision. You have a large tracking area if you have a lot of cameras. But unfortunately here you also do need an external computer to position the actual position of the Crazyflie, which might be a bit difficult if you, for instance, want to fly swarms. We also have what we call a local positioning system. So that is if you use ultra wideband beacons. So that positioning system has about centimeter precision, and the distance between one of these beacons, so one on the ground and one on the Crazyflie, is about 200 meters. So you can have a very large tracking area. And also here, the Crazyflie itself knows where it is. So all the positioning estimation is done on board. So something that we're also quite excited about, as of a year or 2 years, we started to use the HTC Vive VR system for positioning. So these are the HTC Vive base stations, which are pretty much only infrared transmitters. And then we have something on the Crazyflie that's able to detect those sweeps actually. So that's, yeah, so that's also able to do positioning on board. Also, if you compare it to the LPS system right here, this has centimeter precision, this has millimeter precision. So I'm now going to switch, stop sharing the screen for now, because I guess I do want you guys to see this. I'm going to show you a very quick demonstration. As you maybe have noticed, I actually have it right here, the Lighthouse system. So I have one right here and one right here. And now I'm going to make the Crazyflie actually fly based on this. So let me just get to the scripts. All right. All right, so I hope everybody's seeing the Crazyflie. I also have like a webcam called Crazycam, so you can also see it a bit closer. So it's currently using these base stations for positioning. So that's yeah, it's a pretty nice nifty thing, especially if you want to make a flight arena in your own kitchen. So there's nothing underneath. You can plug one of the base stations. It will become a little bit unstable, but still able to handle that. So, all right, let me just turn this off. Cool. So let me just show you what you can, cool things you can do with it. Did everybody is able to see those, the Crazyflie doing all those things? Great. Awesome. All right, so yeah, that's the fun things that you can do with the Lighthouse position. So I just want to show you guys a demo right here because it's actually quite handy to have something like this in your own living room. That's a bit more difficult to do that with a mocap system. So let's see how we are with time. We're still pretty good. Okay, let me just switch back to the slides. One moment. Okay, and we're back. So there's actually, secretively, there is a fourth positioning system. So that is actually the Flowdeck, which you guys are going to use. And that's actually relative positioning.
Kimberly, sorry to, can you hear me? Sorry to interrupt. Like Dario had a question in the chat room, I will forward it here. Like, how does the quadrotor will position itself when you block the base station? Like,
oh, sorry. Thank you for. I didn't notice the chat is a bit small, so maybe I have
no
to.
problem.
All right. Yeah, Dario. So if both base stations are blocked, it will use this IMU for positioning. So it's able to do that pretty well for a short amount of time. So for instance, also during a demo, we also had it flying underneath a chair and it's able to do that quite well. But if you do them more than, I would say, than 4 or 5 seconds, then it might get a bit tough. But in general, it's able to do positioning with just one base station as well. Okay. Thank you for your question, by the way. Okay. So to give you kind of an overview of the client software that we use. So like I said, we also have ways that you're able to connect with your Crazyflie through your phone if you want to quickly test out the motors. But I'm mostly going to focus on how you're able to communicate with it through the computer. And then mostly in particular, it's going to be about the PC client of the Crazyflie. I believe that you are also going to have a tutorial about the Python library, so I'm not going to go into that. I'm going to mostly introduce you guys to the PC client. But before we do that, I'm just going to explain how the communication works. So you pretty much need a Crazyradio PA, which is one of these. You see it on the picture right here, which uses the Crazyradio real-time protocol to communicate with the Crazyflie. I'm not going to go into that because there's too little time, but I think the most important thing or takeaway that you guys have to think about is the URI that it's communicating with. So this is the URI, the unique URI per Crazyflie, which this says about the medium. Well, this radio means you're using this one, but you can also communicate through USB, through serial, where the 0 and 1 stands for which radio you're actually using. 80 is a channel, so you can go from 10 to 120. This stands for the speed, so this stands for 2 mbits per second, and the E7 system hexadecimal ID per Crazyflie. So it is actually possible to broadcast to multiple Crazyflie as long as they're on the same channel. That's perfectly fine, and they have to have a unique ID. but I don't think you guys are going to really focus on that, so I'm not going to go too much into that in detail with that. Okay, so I'm going to plug this in now. I'm going to connect to one of my Crazyflies right here, so you guys can see it for yourself. And let me just open up. Oops. So this is the CFclient. So this is the flight control tab. You can see here what the angles are doing. You can also add a controller to it as well. So I'm first going to connect to it. So my Crazyflie has ID 0105 at the end. So if I then press scan, first I have to turn on the Crazyflie, very important. Scan. Then it's able to find it. It's on channel 56. All right. So then you can actually see it's connected. You're able to see the battery level and the link quality. And yeah, that's pretty much what you need to kind of read out these values. I will go more into detail here later. So let's first go back to the presentation. All right. So I think the most important hardware that you guys want to know about is that the Crazyflie has two microprocessors. One is an STM32F4 and one is an NRF51. The STM is the actual autopilot microprocessor, so that you can actually find on the bottom if you look at the Crazyflie. The NRF is on the top. So this is the top, this is the bottom. The IMU, which is also very important to you guys, is also on the top. But I guess it's also very more important to actually understand the connections between them. So the NRF microprocessor mostly handles the communication between the computer and the Crazyflie. So it gets all the packages in. And it's able to do that also in parallel with the STM, which is handles the main autopilot. So that's where the controllers are, that's where the state estimators are, that's everything that you need for flying. But it's pretty handy to have something in the background that's handling the communication and power distribution. So that's why we actually have two microprocessors. Let's see. So yeah, that's going to be anything else that I have to explain about this? No, not necessarily. So I'm just going to focus a bit on the IMU. So that is, I guess you guys should know what an IMU is. So accelerometers, you can have the acceleration in different directions. The gyroscope is actually how quick the angles are moving. And the pressure sensor, that's mostly for height estimation. So you have a different pressure here than here. And that's how you're able to get kind of height. So let's see how that looks like in the CFclient if I connect with it again. So you see here, it's still on the same address. So I connect. So you already saw that you can already see the angles right here. But you also have some other nifty tools that you can use here. So if you go to View, Tabs, Plotter, and then you can open up the plotter thing, you can actually look also in a kind of a logging style of like how the sensors actually progress. And I think it's also very important if you, for instance, want to log something else. There's already a couple of presets ones here, but if you want to make your own logging configuration, for instance, I want to see the raw gyro measurements. Let's see, a logging of 100 milliseconds. Gyro, where are you? Yes, there you are. Save. And then you're able to show that. And then you're actually able to see what the gyro measurements are. So if I put it at an angle, then it will still be 0 because it's not moving. But you see, once I move it here in the X direction, you can actually see it moving. It's a bit noisy, and that's why we have state estimators. But if you're interested in into like the raw values, this is a very handy thing to look at. All right, let's go back to the slides. We're doing actually pretty good on time. If there's any questions now, I hope everything is still clear until now. I presume so, because I don't see any other questions. All right, so let's see. So the whole thing, I think also one of the strengths of the Crazyflie is that you're able to actually add expansion decks to it. So you can actually make it change a little bit to your own liking. And then you can have, for instance, expansion decks that are more revolved about positioning. So this is the Lighthouse deck. That's the other Crazyflie was flying. I have one right here. That's what these things are using, or these things are being used for. But this is for instance, for a DecoWave ultra-wideband module that's used for the LPS system. But you can also add a micro SD for very quick logging. You can log on the CFclient or in a script. But if you want to have ultra-fast logging, then one of these might be handy. This is a expansion deck that you can use if you want to, for instance, make a charge contactless. So that pretty much flies forever. And these are an LED rings that are being used for shows. And then of course, then you have the Flowdeck, which I'm going to go into detail a bit more. Let's say we have a question from how those expansion decks impact flight performance. Well, they do. Let's say, for instance, you want to fly forever with the QI deck. If you don't have a wireless charger, this one actually weighs about 5 grams, and that will take away from this normal 6-minute flight time. It will just be a 4-minute flight time. Agility, that is mostly the question, like it's able to carry 15 grams in total. But if you come close to those 50 grams, you already have something that weighs 13 grams or 12 grams. The motors have to work really hard to keep that up. So then you will also lose some agility as well. Yeah, and I guess, yeah, so it's pretty much a weight, more of a weight issue than, but it's also a power thing as well. Like during my own research, I actually added also a camera on top. And there was also with one of the multi-ranger with the Ranger lane sensors. And that was already on the border. Not necessarily if I turn the camera off on the Crazyflie, it was able to fly fine. When it was on, it wasn't. So power is definitely also a big factor here. But yeah, it's, yeah. About average expansion deck, about 1 or 2 grams, I would say. So yeah. But except for the QI deck, the one here, that one is a big one. Okay, great. Any more questions? Thank you. All right. Okay, so yeah, of course, the Flowdeck is the one that you guys are going to work for. So I'm going to show you the actual sensors on that. So we have a PMW Pixart's optical flow sensor, which does not calculate speed, it calculates how quickly the image moves. And then you also have a VL53L1X range sensor, so you can find all the specifics on our website, but that's pretty much for detecting height. And that is able to detect height up to 4 meters. So then it can actually, it can actually fly pretty high, but I guess if you want to fly here, I think 1.5 meters will already do. So yeah, that is, and also think about, like I said, this is also a positioning system in general. It's just on board. The only thing is the big difference for the Lighthouse system, for instance, that has a X, Y, and Z0 here somewhere on the floor. So that more of a global positioning system. So if you put the Crazyflie here, it will also be minus X plus Y, something like that. With the Flowdeck, wherever you start the Crazyflie, that's where its initial coordinate system will begin. So that is the important thing to think about if you fly with the Flowdeck. So I'm going to keep repeating that also in the rest of the lecture as well. All right. So I'm going to now put on one of those Flowdecks. So I hope that everybody's able to see that. So I'm going to, you put it here on the bottom. So this is the bottom of the Crazyflie. And then you have to make sure, of course, it's noted which direction it has to look at. And then, see, it's now all connected to the bottom. So let's connect to it again. You cannot see it. Oh, okay. Let me stop share my screen. So this is the, this is the naked Crazyflie. Let me just try to get this. So this is the naked Crazyflie. So it's just, you can fly with this without anything. That's you can pretty much fly it as long as it has a battery. You can fly it with a controller. But if I add the Flowdeck, then you will add sensors to the Crazyflie. You guys are able to see it now? Yes, perfect. Thank you. Okay, so let me just share my screen again. All right, and let's go back to that CFclient. Let's connect to that again. So we have the trusty old plotter. And let's go to login configurations. Let's see. What we now want to do actually is we want to see the motion and range. So let me just first find, there's a variable called motion. Delta X and delta Y are the, let me just first return these. Delta X and delta Y are actually the motion in pixels. And then I also want to show the range. So there's one finger range and Z range. Perfect. Let's see, save. And then you're able to show it right here. That is a good question. Why is it not connecting? Let me just. Ah, that's interesting. Maybe that's the reason. This Crazyflie is actually broken, so. Let me just grab this one right here. Let's make it a bit easier for ourselves. This one is definitely able to. Let's see how we're doing with time. We're doing perfect on time. So I just removed the Lighthouse deck and I put the other one on top. I actually have to change the ID because it's not different. And let's see if we're now able to see something. Yes, we're able to see something now. So maybe I have to zoom a bit in first, because you're able to change the range here as well. So these are not the same units, so it's maybe a bit difficult to actually see something if you're so close. Right, so you're able to see a direction. It looks super noisy, but it's actually able to, the estimator is able to make some sense of it, trust me. Yes, actually, very good question, it does. That's actually a very good opportunity for me to also show you the console. of the CFclient. If we, for instance, go to, that's the raw, Fabrizio, that's the raw data that we're looking at. I'm going to show you the state estimation later. So, but first I'm going to show you the console. So this is the console where you can actually see all the starting up data from your Crazyflie. So let's connect with it again. And it's also a very good way to test if it's actually detecting the Flowdeck. And here you can actually see that it's found one deck, and it initializes, it has a ZDO sensor, and it has a motion chip. So if you're unsure if the Flowdeck is actually being detected, or you, for instance, don't see the flow data like I did before with the other Crazyflie, which is apparently broken, then this is also a very good way to kind of check, okay, is everything going okay? So, are there any other questions? So, Noe, does that answer your question as well? Yeah, cool. So yeah, so this is also very nifty. For instance, if your Crazyflie suddenly drops out of the sky because you programmed something weird in it, usually it will say here, if you connect to it again, it usually says here what actually went wrong with your coding. So this is also definitely a very handy tab to think of, so that you can just find right here. Okay, actually went a bit quicker than expected. I guess it will be okay to already show you a little bit about what I did during my PhD, where I actually used the Flowdeck and the multi-ranger by itself. So this is just a quick video of the Crazyflies flying without any positioning systems, and just with the multi-ranger to avoid the obstacles. So they were actually following all the walls and trying to avoid each other when they came close, and then try to find their way back. So in the slide, the link, or at least the reference to my website, is to the paper is present, so you can also read it for yourself. So yeah, I think actually I covered everything that I wanted to know, wanted to say for the first hour. So I already gave you a little bit for the second hour, but I think that's just fine, because then we can show more cool stuff in the second hour. Was everything clear? Does anybody have any questions? We have about 5 minutes until 12, so.
I think that if no one has any question, we can stop here and start at 12:10, basically. And we have a bit more than 15 minutes to rest. And thank you. I will stop the recording now, and I'll see you on the other link, okay?
Yeah, perfect. Okay, great.
Thank you.